be able to identify the conic from the equation. So that's where you look for, are x and y both squared? Are they both, are the coefficients the same? Or there is one plus, is one minus? You remember that kind of stuff? So for example, if there were an x in the equation and a y squared in the equation, you know it would be a parabola, right? If both x and y are squared and they're both positive, you know it's either going to be a hyperbola or, an ellipse or a circle. If there was an x squared and y squared and one were being subtracted, you know it would be a hyperbola. Okay, it's been a while, so it's good we're reviewing that. Maybe you now have in your mind what you should know. Okay, so that's what we mean by identify the conic from the equation. You also have to be able to go from the equation to the graph, obviously. We didn't really do a lot where you went from the graph back to the equation, but we did give you what is called sufficient conditions. And from sufficient conditions, you come up with the equation and graph. Okay, so by sufficient conditions, does anyone know what we mean by that? Or give us an example. Doesn't have to be a perfect example, but just something where we have conditions. Yeah.
Foci?
Okay. So you have the foci or the foci, and maybe the vertices or the co-vertices. For a parabola, they could give you the directrix and the vertex or something like that. So that's what we mean by sufficient conditions. And something else you have to be able to do is complete the square. So we can work through an example of each of these. The examples in the notes are pretty similar. We have an equation and we're going to graph. We have to state the type of conic section and how you know, so that would be identify, and we're given some sufficient conditions. Okay. So this is overview what you should be able to do for conics. And again, all that information sitting right in front of you. So let me first, before we get into these, let me give you an example of completing the square. Okay. So the instructions ask you to complete the square. We're trying to turn this equation into transformation form. So we have 16x squared plus 4y squared plus 32x minus 8y equals 44. And we're supposed to complete the square. So for completing the square, what do you have in mind? It's an expression you have in your brain that when the instructions say complete the square, you know you're supposed to, Haley,
Take half and square.
take half and square. Good. What do we take half of?
The second.
The second, or the middle term. Cool. All right, so before we complete the square, let's identify the conic.
Oh, it's hold on.
Ellipse?
It's an ellipse. All right, how come?
Because the two x squared terms are positive.
All right, because we have an x squared and a y squared, so we know that it's not a parabola. Both of these coefficients are positive, so we know it's not a hyperbola. And because these coefficients are different, we know it's not a circle. If this were a 4x squared and a 4y squared, it would be a circle. But because these are different, it's going to be an ellipse. If this were 16x squared minus 4y squared, it would be a hyperbola. Okay, 16x squared plus 4y squared. We know it's going to be an ellipse. Good detective work. Okay, so to complete the square, we are going to separate the x stuff from the y stuff. 4y squared minus 8y and equals 44. Okay, so we're separating the x stuff from the y stuff. The constant term or the number goes on the right-hand side, and we're not ready to, so Haley is reminding us we have to take half and square it. Yes, it's going to be the b term or the middle term that we take half and square, but we can't take half of 32 just yet. What do we have to do?
You have to take out 16.
All right, we have to factor out the 16. So in order for that take half and square it to actually work, we need to have a positive 1x squared or a positive 1y squared. So we're going to factor out a 16 inside parentheses, positive 1x squared plus 2x. All right, and I'm going to leave some space. And Haley, from the y stuff, what would we factor?
The 4.
Factor out the 4. Good. Y squared minus 2y and blank. Okay. Great. And if you leave space here, it will be a lot easier for you. So, we're going to take half of 2 and get 1, and square it and get 1. What do we do with that 1?
Put it in the blank.
Put it in the blank. So we're going to, if this were an Algebra 1 style question, we would take that and add it to both sides of the equation. Okay? But we are adding 1 here, and the whole purpose of this is so that this trinomial can be factored into something squared, or a binomial squared. Okay. Did I just add 1 to both sides? No. And so that's the tricky point. And students mess this up all the time. They add 1 here, and then they add 1 over here. You didn't add 1, you added 16 times 1. Okay, so you have a plus 1 there. You should have a plus 16 over here. Okay, because again, 16 times 1. And for the y stuff, we're going to take half of that negative 2, which is negative 1. We're going to square it, which gives us a plus 1. And we add that here. We didn't just add 1 to the left-hand side, we added 4. Good. So 4 times 1 is 4, and we're going to add 4 over here. Okay, so we have now 16 times, and we're going to do this all in one step. When we factor the x squared plus 2x plus 1, we can write it as x plus 1 quantity squared. Good. X plus 1 quantity squared. So this is looking like where we'll find the x coordinate of the center. Plus 4 times y minus 1 quantity squared. And on the right, it looks like we have 64. So if you're working through a question like this and you see these perfect squares all over the place, you kind of know you're on the right track. It looks good. All right. We're going to have to do one more thing in order to turn this into the equation of an ellipse with which we are familiar, and that is divide. What will we divide both sides by? 64. Great. You're familiar with having 1 on the right-hand side for this ellipse. So after dividing by 64, and each of these terms gets divided, 64, 64, 64. So this becomes, great, x plus 1 squared over 4 plus y minus 1 quantity squared over 16 equals 1. Cool. So this is looking like an ellipse. Both of these are positive terms. These are different. Okay. Questions?
Can you write down what makes